This is Note-Taking Guide 4.1, Inverse Functions and Their Graphs. So first I want to just talk about what an inverse is. So let's just kind of look at this magic trick that you've probably heard over the years. If you take a magic number, so any number that you want, think about it in your head right now, and then do these things with it. Okay? So pick a number, any number. Get that number in your head right now or write it down on your piece of paper. Then add 6 to it. Multiply by 2. Subtract 12. And then divide by 2. And then, guess what? The answer is the number that you started out with. How come that happened the way that it did? Well, right here it says people are often mystified by such tricks, but those of us who have studied inverse operations and inverse functions can easily figure out how they work and even create our own number tricks. Let's get started by figuring out how inverse functions work together. So the reason that these kinds of tricks up here work together is because what we really do is we undo what we're asking people to do with the number. So if we added 6 and multiplied by 2, that was really like adding 12 to the function. Then I subtracted 12. So we just did one thing and then undid it. Those are what inverses are. So we're going to take a look at some of the examples that are on the next few pages. And we're going to see if we can determine what the inverse function would be. Okay, so here's our first example. If we take the number x, which in this case we're going to say x equals 7, and we put it through this function right here. So the function tells us to put 7 in place of the x right here, so we'd have 7 plus 8, and we show it right here. We would get the number 15. Well, how do I get back to the number 7 from doing that? Well, if I added 8, what am I going to do to get it back to the function is to subtract 8, because subtract 8 is the inverse operation to add 8. Okay. So the next example right here has our x value as 7, and it says to times it by 1/7. So to times by 1/7 gets us the number 1, and then how do we get back to the number 7 from there? Well, we times by 7. So is multiplying by 7 the inverse operation of multiplying by 1/7? And that really is, because multiplying by 1/7 is actually just dividing by the number 7. And if we're dividing by the number 7, then the opposite inverse operation would be multiplying by 7. So here in function form, we would do 7 times x. All right, here's another one. We start out with x equals 7, and we square it, because that's what our function down here tells us to do. Take the x and square it, so we square it to get 49. How do we get from 49 back to 7? Well, what's the inverse operation of squaring something? How do you undo a squared? To undo a square, you have to square root. The square root of 49 would be 7. So in order to write our function down here, we would have to square root x. Because again, the inverse operation of a squared is to square root. All right, here's another one. We start with x equals 7. And this time on our function, we have you doing two different things. We times by 2, and then we we subtract 5. So timesing by 2, we'd have 2 times 7, which is 14. And 14 minus 5 equals 9. So the question is, how do we get back from to the number 7 from there? So what do you think? Are we going to add 5 first, or are we going to divide by 2 first? Why don't you guys try it a couple of different ways and tell me what you think. All right, so because the last operation we did was minus 5, the first operation this time we're going to do is add 5. So we're going to take the x value and add 5 to it, so that would be 7 plus 5, which is 12. All right, when I said that, I knew I said that wrong because I said 7 plus 5, but I really am taking the 9 right here and doing 9 plus 5. So far I'd have 9 plus 5, which is 14. And how do I get the 14 to be the 7? Then I divide that whole thing by the number 2. So this time when we wrote our function, we'd have to have the x plus 5 on the top of the fraction and the 2 on the bottom of the fraction. So again, it's because we've got to take this 9 right here and get it back to the 7 by doing the inverse operations. So because I subtracted 5 last, I have to add 5 first. And then because I times by 2, I have to divide by 2. All right, here's a couple more to see what we're doing here. So this time we have x plus 5 over 3 for our function. So we put the 7 in there. We're going to add the 5 to it to get the 12. The 12 divided by 3 gives us 4. So again, how are we going to find the inverse of this? Now some of you guys are probably like, okay, we got this, Mrs. Clark, we're done with this, let's move on. Well, I want to just start showing you the algebra way to do it, because sometimes you're thinking, well, what should I do first? Should I add the 5 first? Should I divide by 3 first? Should I divide by 3, add the 5, multiply? What should I do first? So I want to show you what we're going to do algebraically here in just a minute. So the first step for solving for the inverse of function is to realize that that f of x value right there is really just a y value. And we talk about that all the time, that the function of x is just our y value. So the first rule is to interchange that x and the y. So interchange means make the y the x and make the x the y. And then I get to just solve this equation, which looks kind of messy, but it's going to turn out pretty nice. So if I want to get y by itself, I'd have to get rid of the 3 first. To get rid of the 3, I would have to times both sides by 3. So over here I have 3x, and over here I'd have y plus 5. And then again, to get y by itself one more time, I'm going to subtract 5 to the other side, because the inverse of adding 5 is subtract 5. So I would have 3x minus 5 equals y for my function. So let's just talk about how we did that in what order according to our original problem. So the original problem said to add 5 and divide by 3. So to undo what we did, the first thing we had to do was multiply by 3, because it was the last thing we did to our original one. We multiplied 3 and then we subtracted 5. So whatever the last function is that you do to your original function, it is the first thing you're going to undo on the inverse function. All right, so again, you could do the algebraic method that I just showed you, where you interchange the x and y to solve these, or you can just look at the pattern and see what happens. You start with 7 and you put it through 1/3 x plus 5. So you get to 22 thirds. How do you get from 22 thirds back to 7 is the big question. Now again, I really don't like to think about the numbers and what to do, especially once I'm starting to look at a fraction. So I really would rather replace that f of x with a y and then interchange the variables. So the y becomes the x and the x becomes the y, and I seriously just solve again for y. So use that cover up method where you cover up that 1/3 y with your finger, and then it tells you what you have to move. You're going to minus that 5 over to the other side. So you'll have x minus 5 equals 1/3 y. And then how do you get rid of multiplying by 1/3? Well, you times by 3. So you're going to times both sides here by 3 so that you can figure out your solution. So that will be 3x minus 15 equals y. The y really though is an f of x, so right here I'm going to change it to the inverse f of x right here. So you could write this down here as 3x minus 15, or you could have written that as 3 times x minus 5, which makes more sense when you think about the inverse, because the last thing we did was add 5, which means the first thing we had to do was subtract the 5. And then the first thing we did was multiply by 1/3, which means to undo the multiply by 1/3, we would have had to multiply by 3. So again, I would rather just do the algebra than to guess. But again, if you're looking at the pattern here and do the last thing that you did first and then go from there. So the last thing we did was the plus 5, so we had to subtract it. And then we had, before that, multiplied by 1/3, which means we needed to multiply by 3. All right, so this next section is where we're going to look at what the inverse looks like on a graph. So I just want you to take note of these graphs that are inverses of each other. And you guys tell me what you might discover here. So inverses, first of all, are mirror images of each other over a special line. And down here, right here, it says to graph the line y equals x on the graphs and to see what you notice. So let's just talk about that for a minute and let's just graph that line. Well, if you remember how to graph the line y equals x, that would be y equals 1x plus 0 because of the slope y-intercept form. So we would start at 0, and we go up 1 and over 1, which is this line that goes through the very center of the graph. Now, if you notice on that, these ordered pairs are reflections of each other over that line. So if you picked a point up here on the graph right here, it would reflect itself over here. If you folded the paper along this line right here, you would have these two lines on top of each other over that folded piece. So again, the same thing here, that line y equals x goes right through the diagonal here. And if we folded our paper in half on this line, these would be directly on top of each other. Same thing here would happen, and the same thing here would happen. So inverses of each other, if we're talking about them graphically, are the reflections of the original graph over the line y equals x. Okay? So you can tell whether or not you're looking at a graph and its inverse by determining whether or not it looks exactly like itself flipped over that line. Okay? All right, so here's some questions that goes along with those graphs. Number 10 says, look at graph A, and it says, shade the two triangles made up by the x-axis and the y-axis. Okay, and then it says, what is interesting about those two triangles? So go back and look at graph A and shade the two triangles made up by the x and y axis and each of the lines. So let's go back and look at that. Let me erase my original graph here. So right here would be one of the triangles that's made up from the x and y axis and the line. And then on the other side, this would be this triangle. So again, just notice there that those are reflections of each other. This point right here reflected over to here. That point here reflected to here. It might be important at this point to just bring up the point that the way the ordered pairs reflect. So this graph is really hard to read on here, but I think that this ordered pair right here is 8, 0. And I just want you to notice that that ordered pair 8, 0, when you reflect it over the line y equals x, it becomes 0, 8. So what happened right there? We interchanged the x and the y. Do you remember how I just showed you how to do that algebraically just a minute ago? Where I said change the x and the y value? That's what we did here. We interchanged the x and the y value on the ordered pairs. Okay, number 11 says, based on your work today, what relationship do you notice between the graphs of a function and the graph of the inverse function? Well, what we noticed is that they reflect over y equals x, and we noticed that their ordered pairs are interchanged. So we could say that x becomes y and y becomes x. We interchange the x and y ordered pairs. Okay. All right, number 12 here says graph C is shown again below with some of the specific points on the original, which is the solid one. So this one right here is our f of x graph. And then our inverse graph which is represented by that -1 sign there. Our inverse graph is this top one up here. Okay, so f of -1 of x. It says create a table for the values on both tables. And again, this is just to show you what's going to happen here. So let's take a look at this ordered pair right here. This is the ordered pair 1, -2, and it's on my original graph. So 1, -2 actually becomes on the other graph, -2, +1. You see how those two are the reflection over that line together? So this is just another example to show you that to find the inverse of a function, we simply interchange the x and the y values. So let's just check another one to make sure it works. This is -3, -4, and its inverse point would be -4, -3. So again, simply all we did was interchange the x and the y values. So how do we find the inverse of a function? We change the x to y, we change the y to x, and we resolve. If we need to just find the inverse of an ordered pair, we just simply change the x value to the y value and change the y value to the x value. All right, so here's an example of how to do that algebraically, and I already showed you that just a second ago, but this example walks through it step by step. But I do like that it gives you step-by-step instructions here. Okay, step 1 says rewrite the function with a y instead of an f of x. So this one says find the inverse function if f of x is this. So what we did was we took it and we rewrote it with a y instead of an f of x. Step 2 is to switch the x and the y. So this was the y, it becomes the x. This was the x, it becomes the y. And then the last step is to solve for y, or put it back into standard form. So they took this equation here, or function, and they solved it for y. They added, to get rid of the add 1, they subtracted the 1 to the other side. To get rid of the times by 1/4, they multiplied both sides by 4. They got their function, and again right here they decided they were going to distribute it through. They got their function in y equals form, and then they simply just had to rewrite the function, changing the y back to a f of x instead. And anytime we find the inverse of the function, we denote that function with the f -1 of x symbol, meaning the inverse function, so we know what we're doing there. All right, let's try an example of doing this on our own. We've already done it because I showed you on some of the earlier problems, but it says to find the inverse of g, and then it gives us the g function. So the very first thing we're going to do is we're going to change that g of x to a y. So we have y equals 2x minus 3. So that's step 1, change the g of x to a y. Step 2 says switch the y and the x. So the y becomes the x, and the x becomes the y. And then the last step is to solve. So we're solving for y, which means we're getting y by itself on one side of the equation, and then you're just going to do that cover-up method that I've taught you. So cover up where the y is, that means you would cover up that 2y. The stuff that's kind of hanging out there that has to be moved is the 3, so we're going to add 3 to the other side because it was a -3. So I get x plus 3 on this side, and on the other side I get 2 times y. How do I get rid of a 2 times the y? Well, I do the inverse of multiply, which would be divide. You're going to have to divide everything by 2. When you do that, on this side you could leave it written like this, or you could separate it to x over 2 plus 3 over 2. It doesn't really matter which way you do it. It kind of depends on how you like to look at it. I would almost rather look at it this way, but it doesn't matter. And then that last step is to change it back to the g of x. So I'm just going to rewrite it one more time up here. So this y right here became my inverse g of x right there. And I would just have the x over 2 plus 3 over 2. And if you didn't want that x up there on top, how else could you write that? You could write that as 1/2 x so that it's in linear form. So how would we know if those two really were functions of each other or inverse functions of each other? Well, we could graph them and see what they both looked like. And I'm just going to sketch a really quick graph here. It's not going to be perfect because I clearly didn't draw my axis very good. But if I drew the graph of 2x minus 3, I would start down at 3 with a point. I would go up 2 and over 1. So I'm kind of through this spot right here. Then if I were to graph my new inverse, which is 1/2 x plus 3/2. 3/2 is like 1.5, so I'm going to start right here. And then I'm going to go up 1 and over 2, which is like right here. And I'm going to look to see if that looks like it's an inverse of each other over this line. And even though my graph is not accurate, they do look like they're mirror images of each other over that line, so it looks like we're good to go. Okay, that's the last example on this note-taking guide, but knowing what the worksheet looks like, I just want to review a couple of rules with you because the worksheet does review some rules on powers. So I just want to remind you that if you have something like a to the 5th times a to the 4th, how many a's do you have there? Well, that would be a to the 9th. Oh my gosh, it won't let me write 9 right there. Okay, 9. Just another reminder too, like if you have x to the 7th over x to the 4th, you would subtract those powers this time. So you would have x to the 3rd. There's just a really quick exponential review on this worksheet today, so I just want to make sure that you remember your rules. If you have a power raised to a power, like m squared to the 3rd power, that's when you get to multiply those powers together, so that would be m to the 6th. Then just a reminder, and you can see this if you look up at my clock, you'll remember this rule. But what if I have a number raised to a 0 power? That's always equal to the number 1. Okay, you guys, good luck on your assignment. Thanks for staying with me.